Smart Sea School provides hands-on training on the Celtic Voyager research vessel.
You might not be able to dig grab there at all. But the only time I've ever really sampled around here is last year, and we kind of stopped around here, and we tried a few stations there, but all we were bringing up was like bits of weed.
So this is the day grab going overboard, and the day grab is designed to take a sample of sediment from the seabed. It's the grab we use most commonly because it's the most reliable. It's reliable in the sense that it makes good contact, and it makes good contact with the seabed, and it generally does produce a sample for us. Deployment of the day grab is entirely the remit of the crew. You can see it's a very heavy piece of equipment. It's weighted and it's made of stainless steel, and there's a lot of safety considerations when you're deploying this. And really, it's people who are out all the time using this kind of equipment. They're the people who should do it, and they're the crew.
What we usually do is we use a ruler to estimate how much mud is in the sample, and we do that by
So
going
when the day grab comes on board, it sits into this frame, and we open the lid on it and we use a ruler to measure the sediment depth. What this ruler is telling us is that the sediment is going to 8 centimeters deep at this spot. And of course we've recorded the GIS data for this place, so that if we need to, we can go back again and take a sample to measure if there's any disturbance here. We use the day grab for looking at grain size of seafloor sediments, the distribution of fauna in the seafloor, and we also use it for ground truthing acoustic data acquired for seabed mapping.
You don't need a lot, maybe kind of half a tennis ball. That'll be fine. Okay, if you wouldn't mind, actually, would you put the white label in here?
In the actual, in the bag?
In that bag, yeah. Put the white label in there. And you obviously don't want the white label to punch through the bag. So if you roll it flat, and then try and squeeze this to get the air out, you'll find that even though these things aren't very big, they take up an awful lot of space in the freezer. So then we freeze that because bacteria in the sediment will be kind of digesting the very fine material, the organic matter and the mud in it, and they can change the grain size distribution, and they'll also change how much organic content you'll find in it when you analyse it later. So we freeze it at -18 immediately, and then later we defrost it before we analyse it. We take a lot of the stuff that comes off the land either through anthropogenic sources or natural sources, and they reprocess the material and they release it back to the water column in the right form, so that it feeds the type of phytoplankton that we want growing there, and then we get fish and things that we'd like to eat. The guy in the lab who has to identify them if we break them up. Very often that will be the same guy.
So we've emptied the day grab into the tray, and now we've taken it to the sieve washer. And the sieve washer is just that, it's a sieve, and we've got a hose, and what we do is very gently, if you like, try and decant the material in the tray into the sieve. When we operated CTD, it really falls into two, I suppose, realms of operation. The first realm is the activity carried out by the crew on the deck. So the crew on the deck lower the CTD into the water to a depth of about 3 meters, and then transfer operations up to the dry lab, where students under supervision, lower the CTD to 3 meters off the bottom. Yes, you do want to override it. Yeah, now do a start. And for depth, just put your hand on this. And you're going to watch this column of data here. That's 3 meters in depth. So what you can do is ease that forward. And just, ease it. Alright, so you can see that we've had a pretty rapid change in salinity and temperature there. So some element of stratification or layering is going on there. You're watching this, yeah?
Yeah.
So now when this comes up into the water, you lower it down to the depth you want to go to. You identify the structures in the water column you want to sample, and you sample them on the way back up. Now that's one reason for sampling on the way back up. Identifying the structure, the features in the structure that you want to sample. Another reason for sampling on the way back up is that if you actually do it the other way and you start sampling from the top down, what it means is that you're collecting samples in a bottle where the seal is under low pressure. As you bring that down through the depths, that seal is coming under increased pressure, and you could actually get an ingress of water contaminating that surface sample. And that's important because on this boat here we can put the CTD down to 500 meters.
Hello, can you take the CTD out of the water, please?
In your data sheets, and make sure they're clearly labelled so that when you leave the boat that they provide an accurate record of what you've done that can then be taken ashore and used in the post-processing of the data. Students here are collecting water samples from the CTD, and in the wet lab they take the samples in, and with the use of a vacuum pump they filter the water. So what you see there is a vacuum pump in a soft drinks case. So it's in the soft drinks case just to give it protection. When you go to sea, it's very calm today, but it can be very rough with a lot of movement on the boat. So you have to make sure that the equipment you use is fast to the bench and it doesn't fall over, it doesn't get broken or damaged. It's expensive equipment. So what you see here is students filtering a water sample taken from the CTD rosette, and they filter the sample to take samples back to the laboratory on land to process those samples for nutrients. So you can see from the test tube there, the plastic disposable test tubes, that they fill them, and they don't fill them all the way up because they're going to freeze those. This is the beam trawl being prepared for deployment by the crew. The beam trawl is deployed along coordinates decided by the scientists. An important point to note about the Celtic Voyager is that it's a dedicated research vessel, and the crew on it in a lot of cases come from the fishing industry, so they have a lot of expertise in deploying equipment into the water, and probably more important, taking it out. A big part of the crew's job is making sure that the winches, the blocks are fit for purpose. The cables we use are fit for purpose. This is called the cod end, and probably called the cod end because cod were maybe the first fish that were commercially caught in large numbers. So using a crane onto the deck, they're lifting this up, and they can untie the pigtail at the bottom of the cod end or the cod end liner to retrieve the sample. Beam trawling is necessarily destructive, so really we just want a representative sample. We don't want to overdo it and cause a lot of damage to the environment we've just been sampling. So the sample comes from the deck and we place it up. We place it up in the sorting tray, which is just outside the wet lab. So you've got a continuous production line, I suppose you can call it, going from the sorting tray into the wet lab. And we separate the rolls here into two activities. And the people out at the sorting tray, what they're doing is separating the benthos from the fisheries sample. So you can see from the benthos that it seems to be primarily Chinoderms, and we swing out here again, we can see that there's other, we can see some crabs there too, maybe a little bit of seaweed, and that's pretty much it. So we're not in a very varied environment here. Those are some whelk eggs there. The fish we're getting here are mostly flatfish or pleuronectiforms, and we're also getting some gadoids and smaller gadoids. Gadoids are fish, cod-like fishes, and that's entirely consistent with what we've been looking at on the echo sounder for most of the day, which is showing a flat sandy seabed with not a lot of variation.
You see that tray with start, lads? Can you use those? Can you use these for putting the starfish in?
Yeah.
So when we go to sea, we take out data sheets, or rather we take out identification keys to separate the fish into different species. And what you can see here is maybe 5 different species of flatfish. We've got some other species here like this dragonet, which in a commercial fishery would be discarded. SMART is a collaboration between the Marine Institute, Galway-Mayo Institute of Technology, the National University of Ireland Galway, University College Cork and the National Maritime College of Ireland.